This module is about virtualization and grid computing. So for a company, you need many servers to run different types of applications. All your servers are located in a rack together in a secure server room, sometimes called a data center or a server farm. They run all day, and no one really disturbs them unless they need to perform routine maintenance, set up a new server, or fix a problem. Sometimes fixing a problem simply means that one old server is swapped out for a new one. One server might run your databases, one runs your web server, and one runs your business programs. Each is a separate server with an independent operating system. An application runs on each individual server. That's okay, but the server utilization is typically at 5 to 10% because it was designed for a worst-case scenario. No one wants an application server to run slow, so it runs on a big giant server in case the demand rises. Other cost to this type of configuration is the cost of servers themselves and maintenance. If you need to maintain several separate servers instead of just one, it is time-consuming and labor-intensive. Many servers use more power than a few, and it also costs money to maintain a large data center to cool it. End users, people who use the applications, are oblivious to the server configuration. They just do their computing work and don't think twice about the processing power used to accomplish it, unless something goes wrong and the performance is degraded or very, very slow. What virtualization does for the data center is that it allows several applications to run on one machine, one server. The big box represents one server, whereas in the previous slide it was 4 different servers. One server can now run 4 different operating systems and 4 different applications. This will pump up the utilization percentage from 10% to something a little bit higher. Instead of 1,000 servers, you might be able to cut the server number down to 200. Sharing the processing load enables you to get more power from the servers you have instead of running them all at 5%. Further, maintaining and cooling 200 servers is a cost savings in labor and power. Here's an example of how virtualization saved Rigel Capital a bunch of money. It is from allcovered.com, an IT services consulting company, so they have an interest in reporting a great outcome, but virtualization is something everyone is adopting. Rigel is an investment management firm. They needed to do a lot of online training, and it needed to be fast and reliable. They switched from single servers to 2 VMware virtualized servers. The outcome was disaster recovery went from hours to minutes. To create a new server virtually was very easy compared to purchasing new hardware, and then consolidation of servers made it much easier to cool the data center. Grid computing has the same benefit as virtualization. You can utilize the unused processing power of other machines to get work done. Through smart allocation of processing power, requests can be distributed to underutilized machines. The computers are connected together, and a scheduling program distributes the requests to different servers based upon the need for processing power. In the end, the result is better utilization of processing power, and the need for so many machines goes down. It helps companies to finish their work faster and to save money because they use fewer resources more efficiently. Like virtualization, if a company uses grid computing, it is transparent to the end user. It just works, and people don't need to do anything to take advantage of it. Here's another example of how grid computing was deployed. DreamWorks, the company started by Steven Spielberg, creates high-end feature films like Shrek and How to Train Your Dragon. In the 2001 movie Shrek, the movie used 6 terabytes of data and 5 million rendering hours. What's a terabyte? Again, this sounds so big it's hard to comprehend. To give you an idea, Wikipedia's 2010 content was almost 6 terabytes. What is rendering? The animations are all done in wireframe format, then rendered to create the final product that you can look at. It's filling in the wireframes and filling in the animation based on what the animator created it to do. It takes a ton of computer power to do that for a full-length film. 9 years after Shrek, the film How to Train Your Dragon was 100 terabytes of data and took 50 million rendering hours. To accomplish this, DreamWorks had a dedicated server farm that ran grid computing, distributing the processing needs over thousands of servers. Another great oddball example of grid computing is SETI. The SETI Institute seeks to find other forms of life in the universe by examining radio telescope data from space and seeing if any of the signals contain an intelligent signal made by something besides random noise. A project called SETI Home gets companies and individuals to donate their unused processing power to support the processing of all the data that SETI collects. You run SETI at home on your computer and indicate how much and when you want SETI to have access to your processing power. Here we are again. How much processing power is typically used in a server? 5 to 10%. That's not much of the server's capability. What typically runs on a server? An operating system and some applications. What does virtualization mean? Virtualization means that you can run several operating systems and applications in one box instead of a separate box for each operating system. Can grid computing find extraterrestrial life? Well, it hasn't so far, but there's still time.